Good morning, everyone. My name is Maria Dasilica Gadas, and we are here, the group 2, that will discuss the chapter 2, Designing the Highways. Let's start first with the word consistency. So, what is consistency? It is the most important single role in highway design. That is by making every element of the road conforms to the expectation of every driver. Drivers expect the highway agency to provide them with, first, clear information and guidance through a variety of road signs. Second, avoiding abrupt changes in the traffic as well as the road standards. Let's go on to the definition and terms. AASHO, or American Association of State Highway Officials. It was established in 1914 as an association of state, territorial, and District of Columbia Highway Department and the Federal Highway Administration. The name was expanded in 1973 when the Department of Transportation was integrated into the association, renaming AASHO to AASHTO, giving the officials of this agency the power to govern its operation. AASHTO means American Association of State Highway and Transportation Officials. It is an engineering activities were implemented by the standing committees with the task of preparing a specification manual and standards representing the current highway engineering practice. The AASHTO publication includes first, transportation materials specification and tests. Second, a specification of highway bridges. Third is the geometric design standards. And the last one is the numerous policy statement and guidance. Let's go on to roads and highways. This too is defined as strips of land that have been cleared and further improved for the movement of people and goods. Road has somewhat broader application in usage. While generally used to describe a public thoroughfare, it can also refer to railways. Highway. The term was first used in England to describe a public road built by digging ditches in both sides and heaping up the earth in the middle, creating a higher than the adjacent land. The next one is expressway. It is divided or terrestrial highway from through traffic with full and partial control or access and generally provided with grade separation at the major intersection. Freeway. It is an expressway with full control of access. So what is control of access? It is a condition where the right of owner or occupants of adjoining land or other person access to light, air, or view in connection with a highway are fully or partially controlled by public authority. There are two kinds of control of access. The first one is full control of access, and the second one is the partial control of access. The full control access is the authority to control access is exercised to give preference to through traffic by providing access connection to the selected public roads. Partially control of access. It is the authority to control access is exercised to give preference to traffic through street or through highway. It means every street or highway or proportion thereof of the entrance to which vehicular traffic from intersecting street or highway is required by law to stop before entering or crossing the same, and when stop signs are erected as provided in the traffic code. Parkway. It is the arterial highway for non-commercial traffic with full and partial control of access, usually located with a park or urban park-like development. Arterial street. It is the arterial route that carry traffic to the nearest access point through traffic. It is also considered as a make-do substitute for the control access facility volume exceeding about 20,000 vehicles per day. Collected street. From a smaller mesh grid pattern where passengers are picked up from service street and carried to the arterials. Large commercial enterprises or amusement facilities like drive-in theater are mostly fronting arterial roads. Local road. It is a street or road primarily for access to the residents, businesses, and other adjoining properties. It is also defined as a road constructed and maintained by the local government. Highway capacity. It is defined as a minimum number of vehicles that are reasonably expected to pass a given point over a given period of time, usually expressed as a vehicle per hour. There are two conditions in highway capacity. First, under the ideal condition, one fairway line can date about 2,000 passenger car per hour. The second one is the two-lane line road can carry up to 10,000 passenger car per hour in each direction. AADT or ADT, average annual traffic. This is referred to the traffic volume or flow on a highway are measured by the number of vehicles passing a partial situation during a given interval of time. The AASHTO practice classify first the highway as unay, kung ano nila if urban ba or rural. Then, after ana, aya din nila i-classify as fairways, arterials, collectors, or local road lang siya. Cross-section of a typical highway. The cross-section of a typical highway has a latitude of variables to consider such as first, volume of traffic. Second, character of the traffic. Third, speed of the traffic. And lastly, characteristic of the motor vehicle and of the driver. What is road shoulder? It is the portion of the roadway between the edge of the traffic line and the edge of the ditch, gutter, curb, and side slope. The AASHTO requires that it's usually pavement wide and shall be strong enough to support vehicles.
Good morning, everyone. My name is Jinky Pateño. To continue the discussion, my first topic would be the cross-slope design on a highway. Cross-slope is a geometric feature of pavement surfaces. The transverse slope with respect to the horizon. A straight tangent roadway segment is typically designed with normal crown or a crown for the sole purpose of providing sufficient drainage of water away from the roadway. The term crown is used to describe the top of cross slope and the percentage of the slope. For high-type pavement, normal crown has a rooftop shape which peaks in the center of the roadway and falls away from the center line at often 1% and typical rate of 2%. This means for a roadway with 12-foot lanes, the edge of the roadway will be 0.24 feet below the elevation of the center line. This is essential for reducing the likelihood of hydroplaning. As the picture shows, paved and gravel shoulder cross slopes, the side lanes of highways, have different percentages of slopes, wherein paved shoulder cross slope ranges from 3% to 6%, although 4% is the common. For a gravel shoulder, 4% to 6% slope is satisfactory and 7% slope is effective for turf grass surfaces. On parabolic pavement section, the parabolic crown surface makes the center line almost flat unless gutters are sufficiently deep enough to convey water. A combination of uniform slope with parabolic curve used instead of the parabolic sections. Cut or fill slopes means a portion of land surface or area from which soil material is excavated and or filled, forming a slope or embankment. Earth fill of normal height is on a slope of 1:2 ratios, meaning the first number represents the horizontal distance while the second number is vertical distance. Slope of cuts through an ordinary undisturbed earth field remain in place with a ratio of 1:1 slope. On the other hand, rock cuts could be as steep as 1:2 and sometimes 1:4, proven to be stable. There are 3 recommended policy on geometric design, which are number 1, the 6:1 slope ratio could be adopted on embankment less than 1.2 meters high, and 4:1 ratio on a higher field. Number 2, the 2:1 slope is allowed to heights greater than 6 meters. Number 3, cut slope should not be steeper than 2:1 ratio except on solid rock on special kind of soil. Let us now proceed to the number of lanes. The number of lanes in a segment of the highway is determined from the estimated traffic volume for the design year, or the AADT, and highway lane capacity as expected level of service. AASHTO, the American Association of Highway and Transportation Officials, policies accept a dually divided of 16 lanes roadway with 4 lanes in each direction for an inner freeway and 4 more lanes in each direction on the outside. There are some instances where a reversible lane is located at the center of freeways and unbalanced heavy traffic flow. Highway median. A median is the portion of the roadway separating opposing directions of the roadway or local lanes from through travel lanes. Median may be depressed, raised, or flush with the road surface. There are 3 types of medians commonly used in road construction. Here are the 3 most common types of medians. Paint lines. A median can be of a paint line marked with road studs that separates 2 lanes of traffic that run parallel to each other. Such a type of median is also sometimes referred to as median strip. Concrete barriers or NJ barriers. One popular median barrier type is called jersey barriers. These barriers, made of heavy-duty reinforced concrete, are designed to stop vehicles and other hazards from crossing over into oncoming traffic. Curbs. Curbstones are commonly used as road medians, and these curbstones have to withstand several different weather elements. Recently, median in various forms becomes absolute requirement for highways because it offers a variety of advantages, such as it allows drivers to enter and exit highways or roads with less interruption. Medians, further reducing incidences of head-on collisions. Median offers features to beautify roads and also provide a refuge to the pedestrians while crossing the roads. There are 4 means of reducing cross-median accidents. 1. The deterring devices, the non-traversable energy-absorbing devices, the non-traversable rigid bodies, and GM barriers. Next is the grade line. Grade line is defined as longitudinal profile of the highway as a measure of how the center line of the highway rises and falls. The table shows the maximum permissible grades for highways in percent. So there are different grade percents on freeways, rural, urban, collectors rural, and local rural, depending on their design speed. In laying the grade line, the designer has things to consider. Number 1, your earthwork is minimal and consistently meeting sight distances in relation to grade line. Number 2, in mountainous areas, the grade line must be considered balanced excavation against embankments to get the minimum overall cost. 3, in flat area, the grade line is set almost parallel to the ground surface but sufficiently above the ground for drainage purposes. Number 4, Undesirable native soil should be provided with sufficient covering. And number 5, grade line elevations along the river or stream is governed by the expected level of water flood.
Hello, I'm the next reporter, and I'm talking about vertical curve over crest. So there are two curves, crest and sag. So crest is like a hill. So requirements of the vertical curve over crest. So all curves should not be shorter than the established minimum over crest. This is governed by the sight distance requirements, but sometimes a case riding may demand longer curves than sight distance. Some designers prefer no vertical curve to be shorter than 300 meters. ASHTO or ASHTO suggested that the minimum curve of length varies the design speed in meters. The distance equals in 8 times the velocity of in kilometers per hour. So the intermediate point obtained by maximum correction times horizontal distance of the end of curve to the point of squared over all over one half of the length of curve squared. So next is the right of way. So the right of way is the width of your road. So the acquisition of land right of way is expensive. Highway agency considers acquiring right of way wide enough to provide for an expected development. When expressway and freeway are successful, it closes the roadway from the direct access point to adjoining property. So frontage road must be permitted to enter connecting cross streets only at a distance at least 100 meters for rural and 60 meters for urban. Next is stopping sight distance. What is stopping sight distance? Stopping sight distance is the longest distance that a driver can see the top of an object 15 cm above the surface. Elements of stopping distance. The distance traveled after the obstruction or object is seen before the driver applies the brake, and the second distance is consumed while the driver applies the brake for the vehicle to stop. So how can you get the braking distance? So D equals T time meter per second squared, or D meter per second squared over 19.6 F. So braking distance on a slope or straight highway. So you can get this by distance is equals to meter per second squared over 19.8 or 2 gravity times F plus G. This is the table of the minimum stopping sight distance of a wet road. The passing sight distance. Passing sight distance is the longest distance that a driver can see the top of an oncoming vehicle, where the driver's eye level is 1.05 meters above the pavement surface. A relation of passing sight distance, algebraic reference of grades, and the length of vertical curve.
Remember that when S is greater than L is equal to 2S minus 943 over A.
If S is less than L, you can get this by L equals AS 2 over 943. F equals M over S squared minus SE over 9.8 RM. So this is the table of the minimum passing sight distance for the two-lane highway. Next is the table of the recommended maximum coefficient of side friction. Road alignment should be consistent. Abrupt change of flat sharp curve or long tangent followed by sharp curve should be avoided because it will only create hazard and invite accident. Having short tangent between two curves considered a poor practice. A long flat curve is accepted at all times. It is pleasing to look at with less probability of future obsolete.
Good day everyone, I am Tiffany Abuel. I will be discussing the circular curves, super elevation runoff, widening curve, island, and lastly the types of interchange. So the circular curves, a vehicle traveling in curved road is subject to centrifugal force. This force is balanced by equal and opposite forces developed through the super elevation and side frictions. However, neither the side friction of the super elevation could overcome nor exceed the maximum control and limit on the sharpness of the curves with a prescribed design speed. What is super elevation runoff? The super elevation runoff curved sections of roadways are usually super elevated. Provision for gradual changes from one point to the other should be considered. The runoff length to vary with the super elevation rate and the design speed with the minimum set for appearance and comfort to riders. And the center line of each individual roadway at profile grade is maintained while raising the outer edge and lowering the inner edge to attain the desired super elevation. We have here the widening of curves. Curves widening is used to automatically create and apply horizontal controls to widen lanes and or edge of pavement lines around curves, moving them further away from the center line at each curve of the controlling alignment. A provision for a wider roadway is necessary on a sharp curve for two lanes pavement under the following reasons. Number 1, to force the drivers to shy away from the pavement edge. 2, to increase the effective transfer vehicle width for the non-tracking of front and the rear wheels. 3, to give additional width due to the slanted position of the front wheel to the road center line. Number 4, for a 7.20 meters wide roadway, an additional width of the 30 centimeters is necessary on an open curved highway. An island is defined area between traffic lanes for control of vehicle movements and for pedestrian refuge. Within an intersection, median is considered an island. This definition makes evident that an island is no single physical type. Island is included in the design of intersection for the following purposes. We have the separation of vehicular flows, separation of conflict, reduction in excessive pavement areas, reduction of traffic and indication of proper use of intersections, arrangement to favor and prominent turning movement, and last, location of traffic and control devices. By channelization, funneling is also effective in preventing overtaking and passing in conflict areas. A well-studied super elevation is an important adjunct to channelization that regulates the vehicle speed and prohibited turns are prevented. Refuge may be provided for turning or crossing vehicles and pedestrians. The driver have to face only one decision at a time, hence conflict can be avoided. It provides location for the traffic control devices like signs. To confine vehicles in a definite location without proper route for vehicles and pedestrians, everyone's action could not be predicted by others, and these are usually the main cause of confusion which lead to accident. Next, the type of interchange. The types and form of freeway interchange require selection of the conformation that is best suited to a particular situation and demand. The function of freeway interchanges are: number 1, to provide separation between two or more traffic arteries. 2, to facilitate the easy transfer of vehicles from one entry to the other or between local roadways and the freeway. The cloverleaf type interchange is recommended for freeway and arterial intersections. Intersecting arterials are separated and free of intersections. The cloverleaf type interchange is recommended for freeway and arterial intersections. Intersecting arterials are separated and free of intersections. Objection to the cloverleaf interchange design: number 1, it requires a large area of land. 2, at higher design speed, more time is consumed just to traverse the longer loops. 3, vehicles making left turn execute 270 feet right turn and travel greater distance, becoming very unpleasant and hazardous due to the sharp curves and steep grades. 4, vehicles leaving to the curved loop in one quadrant with those entering the adjacent loop from the true roadway. So these are the type of interchange designing the highway. We have here the white type of interchanges, T or trumpet, directional interchange, through freeway with rotary flyover with roundabout, diamond interchange, partial clover leaf, and the clover leaf. That's all for my discussion. Thank you for listening.
Good morning, everyone. My name is Rio, and today I'm going to discuss the highway intersection at grade. All highways except freeways have intersection at grade. Intersection area is considered part of every connecting roads. In this area, all crossing and turning movement occur. Number 1. For right angle intersection with little traffic, the use of street sign is more than sufficient. Number 2. For Y intersection or other related conformation where vehicles meet at unfavorable angles may require canalization. Number 3. The flare design will involve the following. A. Widening the entering traffic lane to allow deceleration of the car and clear of through traffic. Letter B. Widening the leaving lanes to provide acceleration and merging from the traffic streams. Number 4. Intersection must accommodate large trucks and the radius of all curves must be sufficient enough to accommodate them. A careful traffic count and projected future improvement must precede the design of all critical sections. Based from the data gathered on traffic count, the lane capacity could be determined, including the number of lanes to be constructed. As you can see in the figure 2.31 interchange at grade, we have the uncanalized T, flared T, and the T with turning roadway. An uncanalized intersection is the simplest kind, where two roads simply cross each other like a plus symbol or a T, with nothing specifically dividing traffic in one direction or on a cross street from traffic going the other direction. While the flared T intersection expand the cross-section of the street, main cross or both. The flaring is often done to accommodate a left turn lane so that left-turning bicycles and motor vehicles are removed from the through traffic stream to increase a capacity at high volume locations and safety on higher speed streets. On the other hand, the figure 2.32 intersection at grade, we have the different types of intersection. We have the Y with turning roadways, the three-leg intersection, the four-leg canalized type intersections, the canalized Y, the rotary intersections roundabout. We also have the parallel type, the flared type, and lastly, we have the four-leg intersections, the uncanalized, and the multi-leg intersections. Next is the freeway entrance and exit. The overall effectiveness of the individual freeway systems is governed by the flow characteristics of vehicles and the driver's behavior near on and off the channel. A single lane on ramp vehicles flows into the outer continuing freeway lane. The design is either a taper blending into the through lane or parallel auxiliary lane parallel to the through lane. In either case, sufficient length is required to allow the vehicles to accelerate and merge into ongoing vehicle stream at a speed near that of the freeway. In the table 2.12, sampling of minimum for freeway on and off the ramps. Freeway speed kilometer per hour on ramp and off ramps. On ramp or off ramp, design speed kilometer per hour. We have stop 20, 30, 40, and 50. L stand for the length of ramps in meter. Freeway speed kilometer per hour on ramp. We have 80, 95, and 110. For 80, the minimum is 228, 189, 150, 48, and 51. For 95, we have 350, 321, 273, 177, and 51. And for the 110, we have the minimum of 477, 450, 400, 303, and 174. For the off-ramps, we have a freeway speed kilometer per hour of 80, 95, and 110. For 80, the minimum is 130, 115, 95, and 68. For the 95, we have 159, 147, 129, 102, and 72. And lastly, for 110, we have the 185, 170, 153, 129, and 102. For the exit, vehicles leaving the freeway need distance to accelerate and clear of the flow of ongoing traffic. In situation where one lane could not meet the traffic demand, two-lane exit is necessary. In that situation, an auxiliary lane must be added to the freeway at least 800 meters before the point of exit. Even with one lane exit, an auxiliary lane is necessary for it reduces confusion and congestions. Next on the line is the railroad highway separation. The main question asked on a railroad and highway separation is which one is to go over, the railroad or the highway? If the highway is to go over the railroad, the structure itself is lighter and the highway load is much smaller than the railroad loads. With regards to the vertical clearance height, the railroad requires a minimum of 7 meters as against 4.80 meters clear distance above the highway. If the highway goes under the railroad, special provision is required for the removal of rainwater that falls within the opposing area. If the groundwater is high in the vicinity of the crossing, the roadway must be sealed against leakage and be made heavy enough to prevent from floating. The last one is the bicycle lane. Bicycle use is now becoming popular due to energy crisis and traffic problems. It requires separate road for the riders that is entirely separate from the vehicular traffic. The design speed is 20 to 30 kilometers per hour for flat section. The width is 2 meters minimum for a two-way travel. The grade of the lane is 5% maximum on short distances. That's all for today and have a great day.